Welcome to This Explainer. Today, we're embarking on an incredible adventure. We're going to discover that the actual secrets of the universe, they aren't just hidden in giant telescopes or like deep underwater trenches. No way. They are literally waiting right out your front door, maybe even in your own local park. We're diving into the wonderful world of science, and I'm going to be your mentor to show you exactly how you can become a real scientist, starting today.
So have you ever jumped in a puddle when it rained, or just kind of looked up and wondered why stars shine? Just think about those everyday mysteries you see all around you. Like, have you ever watched a tiny crawling caterpillar transform into a beautiful flying butterfly? Or have you ever noticed how liquid water suddenly just freezes into solid ice when it gets cold? Well, these aren't just random events. They're actually the exact kind of fascinating mysteries that science helps us unravel.
As you start exploring, I want you to remember this. Science is like a giant and unending jigsaw puzzle. What you should really take away from this explainer is that science, well, it isn't just about memorizing facts in some dusty laboratory. It's a super exciting, totally dynamic way of thinking. Every single time we learn something new, boom, we add another piece to that massive puzzle. And honestly, the only tool you truly need to start putting all those pieces together is your own curiosity.
Section 1. Meet the Field Scientist, Exploring the Wild.
When we think of scientists, we usually picture people in white coats staring into microscopes, right? But a field scientist steps right out into the great outdoors to study nature exactly where it happens. And the best part? You don't need any expensive machines to get started because you already have built-in scientific instruments. A field scientist uses 4 safe senses to gather data: sight, sound, smell, and touch. We definitely leave out taste, just to stay safe outdoors, of course. An observation can be as simple as seeing green leaves on a bush, hearing the sharp call of a bird, feeling the really rough bark of a tree, or even just smelling the damp earth right after it rains.
So I actually have a challenge for you right now. This is the 1-minute observation challenge. Here's the whole shebang. Here's what you need to do. Grab a spare notebook or even just some pieces of paper to create your very own DIY field journal. Then go outside for just 1 single minute. You can even compete against a friend or a family member. Just use those 4 senses we talked about to record as many natural things as you can. Trust me, you'll be absolutely amazed at how much you notice when you simply stop and really pay attention to the world around you.
Moving right along to Section 2, The Scientific Method, Your Step-by-Step Guide.
So now that you're out there making observations, how do we actually turn all that curiosity into real, rigorous science? Well, we master these 5 core steps. First up, we observe. We look at something interesting that we just don't understand. Second, we ask a question and guess a possible answer. Now, in the science world, we call this educated guess a hypothesis. Third, we test this guess by conducting a fun experiment. Fourth, we analyze our results to see what actually happened. And finally, step 5, we conclude. We figure out whether our initial guess was right or wrong.
And here's the really cool thing. Professional scientists use this exact cyclical process to make sure they're solving problems and uncovering the truth in a totally logical way. For example, way back in the 1800s, a super famous scientist named Charles Darwin visited the Galapagos Islands. While he was there, he observed a bunch of different varieties of finchbirds, which really sparked his curiosity. He asked a question about why their beaks were all so totally different, formulated a hypothesis about their environments, and then spent years collecting data to test it. He literally used the exact same loop we're talking about right now.
But hey, the scientific method isn't just for famous explorers. We actually use it unknowingly in our daily lives all the time. Think about like kitchen science. Say you're doing your homework and your pen suddenly just stops writing. What do? Well, you observe the problem. Then you guess that it might be out of ink. Next, you test it by opening the pen and checking the refill. If it's not empty, you analyze that information and guess, maybe the ink just dried up. Or think of someone cooking who wonders why the dal suddenly spilled out of the cooker. Was there too much water? See, you're already thinking like a scientist.
Section 3, Your First Park Experiment, The Ice Cube Race.
Let's put your skills to the test with a real outdoor experiment. As your mentor, I want you to act like a true field scientist to see exactly where an ice cube will melt the fastest. We need to contrast a few different environments. So think about your local park, or maybe just your backyard. You could place one ice cube right on the hot pavement directly in the blazing sun, then put another one hidden away in the cool shade under a large tree, and maybe place a third one nestled deep in the damp grass. But hold on, before you begin, you gotta form your hypothesis. Which spot do you predict will melt the ice cube the fastest and why?
Section 4, Recording Your Discoveries, The Field Journal.
Now, professional scientists never just rely on their memory.
Because let's face it, human memory can easily trick us. Instead, they write down their observations as hard evidence. Here is exactly how you should draw a quick chart in your field journal to track your ice cubes over time. You'll want rows for 3, 5, 10, and 20 minutes, and columns for your 3 locations. At each time interval, you're going to check on your ice cubes and write down exactly what you observe. Like, is the cube still totally solid? Is it kind of melted into a puddle, or is it just totally gone?
Okay, so once your 20 minutes are up and your ice cubes have inevitably melted, you move to the next vital step, analysis. This simply means looking really closely at the gathered results and thinking about what they actually show. It's how you make sense of all that recorded data. You look at your chart to figure out why, say, the ice melted faster in the sun than in the grass. Was it the intense heat of the pavement? Or maybe the grass was sort of insulating the ice? Thinking through all of this leads directly to the final conclusion of your experiment.
Section 5. You are a scientist. Anyone can be one.
I really want to emphasize this. Anyone, and I mean absolutely anyone, who follows these careful steps is working like a real scientist. The process is exactly the same, whether you're some famous astronomer tracking distant stars and galaxies far away, or an awesome amateur field scientist melting ice cubes in your own backyard. So congratulations, field scientist. You have successfully learned how to use the scientific method. You know how to observe your environment, ask really great questions, set up a fair test, record your data accurately in your journal, analyze your findings to reach a solid conclusion. You are now officially equipped to study nature and uncover the incredible secrets of how our world works.
So I'm going to leave you with this final, super exciting question to ponder. What mystery will you solve next in your own neighborhood? The world is literally full of things we don't know yet, just waiting out there to be explored. Maybe you'll investigate which type of bird visits your park the most, or exactly what kind of soil makes the absolute tallest grass. Grab that field journal, step outside, and let your curiosity lead the way. Thanks so much for joining me for this explainer, and hey, happy exploring!